Good morning, everybody. My name is Purra Kiran, and my branch is Mechanical Engineering. Here, my subject is Fluid Mechanics. Here, we can observe that my topic name is Fixed versus Variable Geometric Nozzle Performance. What is fixed and what is variable geometric nozzle performance? We need to see and discuss that. Here, introduction to nozzle performance. Nozzles are critical component in a propulsion system, affecting thrust and efficiency. Fixed and variable geometric nozzles represent two primary design approaches. Understanding their performance difference is essential for optimizing engine performance. Here, overview of a fixed geometric nozzle. Fixed geometric nozzle have a constant shape designed of specific operations conditions. They are simpler and more robust due to their static design. Their nozzles are commonly used in applications with steady, predictable operating environment. An overview of variable geometric nozzles. Variable geometric nozzles can alter their shapes during operations to optimize performance. They incorporate movable components such as pedals or rings for geometric adjustment. And these nozzles are advantageous in engines required wide operations range in flexibility. Now, advantages of fixed geometry nozzles. Fixed nozzles are less complex, leading to lower manufacturing and maintenance cost. They are highly reliable due to favor moving parts. Fixed nozzles are effective in applications with constant operations conditions. Now, advantages of variable geometric nozzles. Variable nozzles improve efficiency across a broader range of flight or operations conditions. They allow for optimal expansions and pressure recovery at different speed and altitude. The adaptability results in better overall engine performance and fuel economy. Now, performance at different operations conditions. Fixed nozzles are optimized for a single set of conditions, limiting their flexibility. Variable nozzles can adjust to maintain optimal performance across advice environment. This adaptability enhances efficiency, especially during the transition such as ascent or descent. Thrust and specific impulsive compression. Fixed nozzle typically provide high thrust at their design point but less efficiently outside it. Variable nozzles can maximize specific impulse by adjusting to current operating conditions. The ability to optimize expansion ratios leads to better overall propulsion efficiency. Propulsions. Now, design complexity and cost consideration. Fixed nozzles are mechanically simpler, resulting in lower initial and maintenance costs. Variable nozzles involves complex mechanism, increasing manufacturing and repair expense. The complexity of variable nozzles must be justified by performance benefits in mission profiles. Now here we can see and observe that mechanical, reliable and durable. Fixed nozzles have favor moving part, which generally enhance reliability. Variable nozzles are more sustainable to mechanical failure due to their adjustable components. Durability considerations are critical when selecting a nozzle, a type of longer term machines. Applications in rocket and jet engine. Fixed nozzles are often used in smaller or less variable engine, such as certain jet engine. Variable nozzles are commonly in high performance rockets and turbines required wide operational range. The choice depends on the specific performance needs and optimal flexible requirement. Impact on fuel efficiency and range. Fixed nozzles may lead to uh, sub suboptimal fuel efficiency outside their design point. Variable nozzles enhance fuel economic by maintaining optimal expansion ratios during operations. Improved efficiency translates into extended range and payload capacity for aerospace vehicles. Now we can see here one of the example of case study like turbojet versus turbofan nozzles. Turbojet engines often utilize fixed nozzles due to their own steady operations condition, and turbofan engines may employ variable nozzles to optimize thrust at different speed. The case studies highlights the trade-off offset between simplicity and adaptability. Now, we can observe that the future trends and innovations. Advance in material and accurate technologies are making variable nozzles more reliable. Hybrid designs are being explored to combine fixed and variable features for optimizing performance. And research continues to improve the efficiency, durability, and cost effectiveness of nozzle system. Here the summary and conclusion. Once we can discuss what we are learning in these sessions. Here, introduction to nozzle performance. Nozzles are critical components and system. They affect thrust and efficiency. And fixed variable geometry nozzle, it represented two primary approaches. And overview of fixed geometric nozzles, it have the constant shape and specific operations condition, and they are simply more robust due to their static design. Through that static design, it may have the simpler, and they have what we call specific of the steady and the predictable operations environmental. Overview of variable geometric nozzles, it have the shape during the operation, optimizing the performance, and movable components, pedals or rings for the geometric adjustment. Advantages of fixed geometric nozzles mean mainly it leading for the lower manufacturing, and it have low cost also, maintaining for the less complex, and it have the higher reliable due to the moving the parts. Through the moving the part, it is high and application with constant operations. Advantages of a variable geometric nozzle, it have range of flight or operations conditions of efficiency and optimal expansions and pressure recovery at a different speed and altitudes. Now, performance at a different operations conditions, limiting their flexibility. That was one of the single set of conditions, and adjust to maintain optimal performance across diverse environmental. Through this adaptability and such things like flexibility, limiting their flexibility means nothing but during that the single set of conditions, it have to optimize the fixed nozzle also. Now, thrust and specific impulsive compression. Fixed nozzle typically provide high thrust. We know that because of the less efficiency, and variable have it has specific impulse, but adjusting the current operations conditions to the applications also. And design complexity and cost consideration. It have the cost means nothing but it have through the repairing and the complex mechanism manufacturing the repairing expensive, justified by performance benefits also. Mechanical reliable versus durable. Reliable means nothing but while in the fixed nozzle it have few moving parts are there. Through that it have the reliable. And in this durability consideration of nozzle, it have the long term emissions because of selecting a nozzles type critically for the failure through the adjusting the components. Applications in rocket and jet engine. In rocket, fixed nozzle are often used for the smaller or less. They are mainly small and less. That was the one thing we need to understand. In variable nozzle, it commonly we can say that the turbofans and that the, what we discuss turbo flexibility are there because of the depending of the specific performance. Here we can observe impact on fuel efficiency and range. Here there was 2 point we need to notice in this is fuel efficiency outside of the engine. That was the one thing. At the same time, optimal expansions ratio during the operations of the capacity of the aerospace vehicles. We need to understand the efficiency of transit to extend that was. Another thing that is case study is turbojet and turbofan nozzle. Turbojet have the steady operations conditions, and turbofan it have the thrust at the different speed. That we need to understand that one thing. Future trends and innovations are making variable nozzles more reliable. That was, and futures for optimized performance. That is also very important, and it improve the efficiency, durability, and cost effectiveness of the nozzle because of the through the research only we can see this was the because innovation means nothing but we need to add somewhat good things for the better applications in the futures and the coming years. Now here with the last slide we can see summary and conclusion. Fixed nozzles often simplicity, cost effectiveness, and reliability for study conditions. Variable nozzles provide superior performance over a wide range of operating conditions. The choice between fixed and variable geometric nozzle depends on specific mission requirement and operational environment. Based on the operational environment, also we can say there was some of the based on the what we call cost effectiveness and reliable also there. In a fixed nozzle, there was cost effectiveness and reliable and study conditions are that was the main thing we need to understand, and they simply offer that. At the same time, in variable nozzle, that was mainly performance over the a range of operational condition, means based on the situations and the applications they can follow the principle of this that. At the last point, that was that both depends on the specific missions and requirement of the environmental, and this was reference or the further reading or the textbook or the papers. At the last, thank you.